All right, geometry. So our second example of these coordinate uh, quadrilateral problems. So I have a quadrilateral, these four vertices. I need to graph that picture. So let's go ahead and do it. Grab the polygon tool. Okay, negative 5, 0 is left 5. Negative 3, 2 is left 3, up 2. 3, 2 is right 3 and up 2. And then 5, 0 is 5 to the right and not up and down. And then just make sure you connect it back to A. And I looked at this, and this looks to me like a trapezoid. And in fact, it looks like an isosceles trapezoid. I know we've briefly touched on trapezoids, but again, I think you can recognize what a trapezoid is. It's an isosceles trapezoid, I think. So to prove that something is an isosceles trapezoid, first of all, we must show that it has one pair of parallel sides. And in this case, it's probably going to be BC and AD. So let's do that real fast. All right. And I'll do it down here with some math type. Remember, you can also just use the plane type, but I'll use math type. So to get the slope of AB, so I'm going to count rise over run, right? Up 2, right 2. So that's a slope of 2 over 2. So I'll come down here. So again, I'm going to type the word slopes just so I know I'm finding the slopes right now. I'll use an M for slope as it is. So slope of AB equals, so it was 2 divided by 2, and that simplifies to 1. Okay. Now, BC is kind of interesting because to get from B to C, you do not rise. So your rise is 0, and you can run 1, 2, 3, 4, 5, 6. So if my rise is 0, that means the top number in my slope is going to be 0. So the slope of BC equals 0 divided by 6. Well, if 0 is your numerator and it's divided by anything other than 0, the answer is going to be 0. And you might know that because BC is horizontal, that it has a slope of 0. Horizontal lines have a slope of 0. Vertical lines have undefined slope. So keep that in mind. Because for a vertical line, your run is 0. Your denominator is 0, and a denominator being 0 is called undefined. Okay, I'll just use my mouse for CD. So to get from C to D, that's going to be down 2 and right 2. So the slope of CD equals negative 2 divided by 2. That's going to be a negative 1. And then to get from D to A, again, rise, none, run from A to D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll run to the right to 10. So my slope of AD is going to be 0 over 10, and that is still 0. And if you look, BC and AD have the same slope. So that means that segment BC, right arrow to the right, find the symbols. Parallel is going to be here, is parallel to, go back to the segments, decorations they call it, is parallel to segment AD. This has one pair of parallel sides. Okay, so right now it's a trapezoid for sure. So now let's see if it's isosceles. Let's find the length of our legs, which would be A, B, and C, D. And to do that, I'll use the rise and run, A, B, and C, D. So to find the length of AB, it's 2 and 2. So AB equals a square root of 2 squared plus 2 squared. That is going to be the square root of 8. And that does not simplify, so leave it alone. We'll do the same thing with CD. CD equals square root. Again, ignore the negatives. It's just 2 squared. Oh, sorry. Ahead of myself. Everything wrong. Geez. 2 squared plus 2 squared. That is also the square root of 8. That does not simplify. Leave it alone. And what did we just show? We just showed that A, B, and CD are parallel, or are congruent. Are congruent. So we just showed that segments AB is congruent to segment CD. And that means that the legs are congruent, so it has congruent legs. And that means you're an isosceles trapezoid. So you confirmed what you thought. Awesome. So that is an example of one pair of parallel sides. Last example coming up in the next video.